Hello and welcome to my YouTube channel. My name is Prakhar and today I will be teaching you how to cook noodles. I mean to say, I will make machine learning as easy as making noodles. So my explanation starts with my nephew, whose name is Arish. He is 1 year old now and I wanted to teach him to differentiate between an apple and a mango. So I planned to show him both fruits, apple and mango, and also say the name while showing. This I have done for 1 week. After 1 week, I tried to test him on his fruit knowledge. Guess what? He was able to differentiate between both fruits correctly. I was impressed. Out of curiosity, I showed him an apple which is yellow in color and a mango which is red in color. This time he messed up and predicted the wrong answer. So, what goes wrong? If we go back, we can see that I have shown Arish only one set of fruits, without any color variety. This might have confused him about the fruit color he had not seen before. So I upgraded my strategy to teach Arish. This time I bought two cartridges filled with variety of apples and mangoes of different colors and shapes. After that, I started showing him a bunch of apples and mangoes for 1 week. There is one point to note. I have separated both cartridges into 80% and 20%. The 80% part I used for teaching Arish and the 20% I kept for testing him. Now it's time to test Arish again. Out of 20 test cases that I have prepared, 18 fruits were correctly predicted by him, despite the color. Arish really impressed me with his prediction. Now let's dig into the terminologies I tried to explain through Arish. Arish brain here is the machine learning model. Teaching him is training the model. Apple and mango buckets are the datasets. Fruits name I spoke while showing fruits to Arish are acting like labels. Data selected for training is the training set. Data selected for test is the test sets. The bunch of fruits selected for training is batch size. Every day of the week is referred to as one epoch. Teaching Arish for 60 minutes is referred to as the inverse of the learning rate. Here is the catch. As lower you set the learning rate, the model will take more time to learn, which means more things or features it can learn. Now we know about what machine learning is. So let's talk about the inside architecture or the algorithm that makes the model learn things. As we know, this is the brain and it consists of 85 billion neurons that communicate with each other to learn things or send messages about the objects that are cold, hot, or scary, to which our model or a body reacts and learn. So, AI researchers tried to mimic these learning features of the brain and devised this structure. It consists of the input layer, hidden layer, and the output layer. In this structure, you can see blue nodes. These nodes are called perceptrons. And the combination of all the perceptrons makes the neural network architecture. Now let's understand what goes inside each perceptron of the neural network. Imagine perceptron as an incubator, where there is a chicken egg. Bits and bytes are the random values that are different for each perceptron. Now the pixel value as the input value goes with the weight and bias value. The formula to calculate it is bias plus input value, that is the pixel value of an image, into weight. The value of this formula will decide the temperature inside the incubator. If it is higher, egg will hatch. The value calculated from this formula will be passed on to the next incubator or the perceptron as input. If the formula value is lower, the incubator temperature will not rise, so the egg will not hatch, and no value will be sent to the next perceptron. The concept here I tried to explain behind incubator and egg hatching is called the activation function, which decides whether the perceptron should be activated or not. Now let's see how a neural network learns from an image. As we know, the image consists of number of pixel values. These pixel values are then normalized by converting them into tensors. After that, they are fed into the neural network. As I have explained previously, each perceptron takes on these values and formulate with a random weight and bias. Now it's the work of the activation function to pass these values further or not. These values are calculated and passed to the output layer. This is called forward propagation. After that, the output is generated, which is matched with the already existing label. If the output matches the label, then the new image is fed into the network. If the output is wrong, which is the case here, then the weight and bias values are updated. This process is called backward propagation. The process of forward and backward propagation goes on till the weights and bias values are updated to predict the correct output. Now we know about neural network and how neural network learns to classify objects. But some things need to be considered from the data point of view. First, data should be balanced. In this case, both images of the fruits should be equal in numbers. If they are not, then data augmentation should be applied by flipping or rotating the images or adding noise to create an illusion of a new image for the model. If the dataset is not balanced, then the model trained would be biased towards one class. Second is the data quality. Data quality, in which the data should be clear, it should be updated, there should be variety in the data, and it should be noise free. Now let's see the model point of view. The model should be fast in predicting the output. The model should have a good accuracy rate. The model should not be overfitted. Overfitting is the term used for the model that performs well in predicting the output for the data it is trained on, but performs badly on test data that it has never seen before. Therefore, model should not be overfitted. Fourth one is that the model should not be underfitted. Underfitting is when the model is not trained properly and predict the output poorly. Both overfitting and underfitting can be avoided by increasing the dataset or the network layer in the model, or by adjusting the hyperparameters like epochs, learning rate, and batch size, etc. This is all about Noodle Network. I hope my explanation is as simple as making noodles. If you like this video, then don't forget to like, share, and subscribe. You can also support me on Patreon to motivate me to make more videos like this.